Hello, thank you for joining our session today on building reliable LLM apps for real. If you're running AI in production, you have probably had the 3 a.m. moment of panic. What if your chatbot is saying something harmful? What if it leaks customer data? What if it just hallucinates something that it shouldn't be doing? So our speaker here today has spent the last 2 years solving exactly that problem. Shreya Rajpal is CEO and co-founder of Guardrails AI. She created the open source Guardrails framework that thousands of developers use to validate AI outputs, prevent hallucinations, and catch problems before they reach users. Her work bridges the gap between AI safety research and the reality of production systems. Since founding Guardrails in 2023, she has raised $7.5 million from SCB 10X, Bloomberg, Meta, and many more. Over the next 30 minutes, we will explore how to move from research to real-world implementation, what actually works when deploying enterprise AI guardrails, and where this entire field is heading as AI gets more powerful and more unpredictable. Shreya Rajpal, thank you for being here.
Yeah, thank you so much for inviting me and for the introduction, Nicha. I'm really excited to be here.
Yeah. Do you want to give a quick introduction to you and Guardrails AI?
Yeah, absolutely. So a little bit about me. My name is Shreya, a CEO and founder of Guardrails AI. The mission at Guardrails is really focused on how can we build tooling and infrastructure to make generative AI very, very reliable. And essentially, a core hypothesis that drove us here was that the tools that we will use for software engineering or the challenges about reliability and determinism in software engineering will look very, very different for the Gen AI era than they've looked, in the past for either deterministic software or traditional machine learning. So can we build the right tooling that is plug and play for developers to, make sure that any application they're building is very trusted, reliable, etc. And that's what we've been kind of focusing on. Before starting Guardrails, I've been working in AI ML for the last 12 years. I got my start doing a lot of research in classical AI at the time and planning problems. And then, did a lot of applied research for robotics and self-driving cars, really thinking about, how can we deploy the most cutting edge machine learning models for self-driving cars, that sense the world around them, looking at system level robustness, etc. And then, before kind of spinning out and starting Guardrails as my own venture, just really productionizing a lot of the things that we saw in self-driving cars into the real world.
Well, thank you for sharing a little bit about you. I'm really glad to have you here. The last few years, we have seen companies working to move from exciting generative AI demo to deriving practical value, and there were a lot of challenges. Some of them are reliability and safety. So can you walk us through specific reliability gaps you discovered when trying to productionize LLM applications and how these compare to deterministic software components that typically enterprise would be using?
Yeah, absolutely. I think it's a great question. I broadly categorize the kinds of reliability challenges that people run into three broad categories. Nisha, you mentioned safety, and safety tends to be a big one, and a lot of AI safety challenges relate to, is my AI just going to be extremely unsafe and harm inducing? For example, will people be able to easily get my AI to generate, for example, recipes for making homemade explosives, etc., which is not something that we want AI to do, or just being sycophants and reinforcing the negative kind of biases, etc., that people might internally have as they're kind of chatting with AI. So that class of challenges tends to be really bucketed into AI safety. I will say over the last 2 years, the models that we get out of the box, from these big model providers such as OpenAI, Anthropic, or open source models such as Qwen, etc., all of them tend to be much more safe out of the box, some more than others, than they were a few years ago. The second set of challenges broadly is security challenges. So how easily can my system be jailbreaked? Is it going to leak private sensitive information, etc.? This is often pretty essential to any enterprises that are deploying these AI systems, at larger scale. And they want to make sure that just because they're on the cutting edge of adopting and deploying AI doesn't mean that they're compromising on any kind of privacy, security principles that are, central to the risk ethos of of that organization. And then the third one, and this actually tends to be like very under discussed typically when we talk about reliability challenges for AI, is really just product metrics or product challenges, which is that AI is only helpful if it truly gives you value. So for example, if you are building an AI customer support agent, that customer support agent should actually be better than, your classic rule-based, chatbot systems, right? It should make an effort to understand what the user's problem is, be able to be flexible on top of that, etc. So is the AI actually doing that? Is it, is it empathetic, for example? Does it have the right tone of voice? Does it respond in a way that's easily digestible by the human on the other side? Does it, hand off to a real human customer agent when the time comes, etc.? So I think all of those product challenges are another big source of reliability, because you want to make sure that the AI agents that you build actually serve, the users and the humans that they're kind of built for.
Yeah, talking about like making sure that the AI that like is built like serve the user, right? Like there's actually a bit of a paradox. Like you're building a tool to validate AI outputs, right? Would love to actually hear from you. Like, how do you validate yourself as a validator? Like, how do you know your guardrails actually work?
Yeah, that's a great question. I think you're right in that, a lot of guardrails. So guardrails, a lot of the most effective guardrails tend to be machine learning models. So guardrails under the hood can either be rules-based systems, such as, anytime somebody, for example, anytime there's something that resembles a phone number, flag that guardrail and filter it out, because that can be, private, sensitive information, etc. So that's typically a rule-based system. They can be, LLM-based guardrail, where you have another LLM kind of checking the output of the first LLM, or they can be kind of small, fine-tuned machine learning models. So I think especially for the latter two categories, there is a paradigm of AI checking AI's work. So how do you trust, the second AI over the first? I think the first is that, there's a lot of like precedence in machine learning for using a stack of models, or using multiple models ends up being more effective than, if you just were to use like a single best performing model. I think a great analogy for this is, imagine, you have a stack of sieves, and the holes in the sieves are in different places, right? So all of the sieves have holes, but the holes are located in different places, so that when you stack it up, the water flows through it, at much less, I guess, efficiency than it would if you only had like, one sieve at a time, right? So I think ensembling in machine learning is a similar idea, and that's kind of like what guardrails draws a lot of inspiration from. I think the second idea is that, like, okay, now that we're in this machine learning domain, what we're really doing is creating models that can catch when some kind of harmful behavior is happening, the kind of harmful behavior I talked about in my last answer. And the process, therefore, is very similar to the process for other machine learning tools, whereas you have a classifier, which is, true or false, given harm detected or not. You create a data set for that classifier. That data set should look like the data set that you're actually going to see in production, and then you iterate over it, right? So you balance out, okay, how accurate can my classifier be on how much latency. So for example, LLMs can often be like really flexible, really accurate, but they're very slow to use. So maybe using a machine learning model might be less flexible, but often can be faster, etc. So you kind of like do all of those trade-offs to find the right cocktail where you have confidence that this is going to perform as well as I want it to.
Thank you for sharing about how your thoughts about this and how it works. So would love to move this from a more theoretical conversation to a more practical conversation. So let's talk about what happens when, say, a Fortune 500 company enterprise try to actually deploy this. So when companies evaluate the cost benefit of implementing, say, guardrails versus simply reprompting or filtering outputs. So how should they go about and think about this? Like, what kind of framework do you recommend, and how do you help them think through the ROI calculation?
Yeah, that's a great question. I think the first thing, just a quick note I'll add, is that a lot of these techniques like reprompting or, filtering out bad outputs, etc., all of those rely on first knowing or being able to detect when a harmful output is generated or when a harmful input is getting passed through. And that's the entire purpose of guardrails. So guardrails are more so than anything to just detect and flag when something harmful is happening. And then, you can take corrective measures such as reprompting or filtering it out, or, maybe using a different pre-canned response, etc. I think in terms of like how Fortune 500 companies think about guardrails, I want to say that more so now than 2 years ago when we first started, Fortune 500 companies have a much better understanding of how to, of a framework for how to build and deploy guardrails, right? And so a very, very common pattern that we see in these large organizations is that there's a centralized service that essentially provides all of the AI platforms and services to all of the members within that organization, right? So whether members of that Fortune 500 company just want to use, a ChatGPT equivalent for work, or they want to build AI agents, etc., using, AI models, all of those AI uses pass through a centralized AI service or AI platform. And typically that contains, like a model gateway that has access to, maybe a enterprise ChatGPT service or ChatGPT account, an enterprise Claude account, enterprise open source model providers, etc. All of those with like their own kind of like authorization setup. So one of the very common patterns that we see is that in this centralized AI platform, you will often have a guardrail service. So the idea is that, let's say you're a Fortune 500 company, you decide that every single AI request that passes through your network should be checked for, sensitive private information being leaked to, even maybe the model providers, right? So let's say somebody's like, PII shouldn't be leaked outside of, your network boundaries to even like OpenAI, etc. So what you will do is institute, organization-wide guardrails on PII filtering and flagging, so that every single AI request that you make is, kind of filtered out. Or even, and any legal topics or AI safety or AI security guardrails you will institute on an entire organization-wide level via the centralized guardrail service that lives around your AI platform. Often we then see a lot of different teams within a large company have different needs for guardrails, right? So some teams might be building chatbots, like an HR chatbot that'll only be used internally. So you already get like the PII guardrails because that's applied everywhere, but you might need, maybe some other guardrails such as hallucination, etc., right? Because you don't want your HR chatbot to hallucinate. So often you can then add you can create your own service endpoint for guardrails for your internal AI chatbot that basically checks for hallucination, etc. Some other company might then be making a customer support bot that works with your human agents, and that'll actually be external customer facing. So then you need a whole other set of guardrails that, your risk team, etc., puts together, but that'll be on your own kind of custom endpoint. So that kind of like, tiered approach where you have like one baseline guardrail service that everybody uses, and then these different guardrail, like endpoints that different teams within a large company are able to kind of set up. I think that two-tier approach we see is pretty common. In terms of the ROI, I will actually say that it's one of the, if you care about deploying as an enterprise, if you care about, deploying AI safely, guardrails are one of the most effective tools in your, just in your toolkit. The way to think about guardrails is it kind of draws a boundary around what your AI can do, right? So AI generally tends to be pretty unpredictable and go, the responses tend to be pretty unbounded, etc. But guardrails are kind of like your last line of defense almost in making sure that, your AI, as varied and unpredictable as it can be, it will never go outside, this boundary that I kind of set for it. So the ROI tends to be pretty high.
Thank you for sharing that. You have seen, adoption patterns across different types of industries, financial services, healthcare, other regulated industries, or what are the most common failure modes enterprises encounter when implementing LLM? And how do your guardrails address industry-specific compliance requirements?
Oh yeah, that's a great. Yeah, I think like it's pretty fascinating, but one of the most common failure points we see are enterprises knowing that they need guardrails because they've been kind of like told by, thought leaders externally that they need guardrails, but not really truly understanding what their custom risks are. So for example, one of the things we see, and I don't want to call out, anybody specific here, but a lot of times when we work with organizations, they're like, oh, we need, for example, like Llama Guard or Shield Gemma, et cetera, right? Which are respectively the guardrail models, that guardrail LLMs that are put out by both Meta and Gemini Google. And they're both amazing models. They're both like really fantastic models, very accurate, very lightweight, et cetera. But the specific harms and risks that they guardrail against are AI safety risks, right? Now, if you're going to production with, let's say, a customer support chatbot, and you are going to be an external facing, chatbot, of course you need those AI safety guardrails, but often you need, your own internal criteria about what is and isn't acceptable for my chatbot or my AI agent to behave in, and we find that companies often aren't opinionated enough in being able to break down what good looks like for them. So what is a good response? What is an unsafe response? Typically, there's not one acceptable definition, right? So there's multiple criteria. So an unsafe response can be one that hallucinates, one that, maybe talks poorly about our own company, or maybe talks like very nicely or very poorly about our competitors, maybe breaks like any local regulations, etc. So there's this kind of like multiple complex criteria that should exist, like some sort of rubric or framework about what a good response looks like and what an unsafe or bad response looks like. And often we find that, especially when it comes to like AI safety or guardrails, companies don't quite know what are their actual real risks and just go off of, like, let's just use like Llama Guard or Shield Gemma, which is often kind of very insufficient. So this is also where, like we launched our second product in our product offering, like after, the input output guardrails, which is basically called Snowglobe AI. And that essentially, simulation tests different applications. So the idea is to, rather than just guessing which guardrails you really need, it like systematically tests your system. So you can actually understand like where your system's strengths are, where its weaknesses are, and then appropriately, use the right guardrail in production.
Yeah, you just mentioned Snowglobe, right? Like, does it mean you're thinking beyond just like reactive filtering to proactive testing? And like, where do you see AI reliability heading?
Yeah, that's exactly right. A lot of Snowglobe is the idea of, AI can often be such a black box because it's so hard to even be able to compute a distribution. Like maybe you can compute a distribution over a model, right? But when you build an agent or something, it's just so hard, especially for organizations and, teams that are doing AI engineering work to kind of like truly understand what are the boundaries of my AI agent, right? Like how does it typically tend to behave? So guardrails are, as I said earlier, your last line of defense to, make sure your AI doesn't go outside the boundaries that you set for it. But proactive testing is the idea where, you proactively kind of like generate very large scale evaluation data sets that are custom for your use case in your organization, and then see how your AI performs on those custom data sets, custom benchmarks for your risks. So for example, I mentioned hallucination, I mentioned AI safety. So you can basically test out how your AI chatbot or AI agent behaves on all of those risks and then get an understanding of like, okay, actually we do really well on hallucinations, but we don't do very well on the tone that our AI agent takes. So therefore, maybe we need to kind of like use the right mitigation strategies for that. So it's a way of kind of like making the user much more educated about the system that they've built.
When we're looking at like AI today, right? Previously, we were thinking about chatbots, text-based, multimodal, but one of the new developments that we are seeing is AI agents. We see AI agents can take actions, book flights, execute trades, send emails, and in 3 years from now, where do you see like AI reliability look like? Because we're not just going to be deploying chatbots, right? But AI might be making medical decisions, managing infrastructure, for example.
Yeah, this is I love this question because I think also when it comes to reliability challenges for AI agents, oh gosh, it's kind of like the Wild West out there, a little bit, So I think essentially when you think about it, even with a single chatbot, nobody quite still knows how to like test it, think about safety, etc. This is also where we do a lot of work, but even now when I talk to organizations, their biggest challenge still continues to be evaling even a single model or chatbot, because it's just so new, like all of the traditional ways of like testing that we knew, don't really work for that anymore. So now when you take that problem, but you apply it to AI agents, often AI agents, have like multiple workflows or loops internally, and you take different branches based on, decisions at different stages, etc. They're most effective when you give the agent a lot of autonomy. But the problem that you have on a single model's reliability now just, exponentially adds up, right? Like where every single step of the way, each step can have that unreliability, and it just like keeps compounding as you go deeper and deeper into the loop. So I think fundamentally the scale of challenge increases. I think the other problem is just even being able to understand what's happening under the hood, ends up being pretty challenging. So typically, all of the how we measure unsafe or unreliable behavior is, to typically look at like outputs, right? Inputs and outputs. But with AI agents, what you really need to be able to do is like inspect, the traces and make sure you're assigning value over like each step of the way, right? To kind of like make sure that there's like reliable behavior there. So I think both of those end up being like slightly different than how we've kind of like solved some of these challenges before. I think the idea of guardrails still continues to hold, but the idea is that like now you need to create a lot more custom guardrails that you add, around your AI agents, etc. So let's say you're building like a complex agent, you want to make sure like maybe some internal step that parses what the intent of the user, etc., is, like that has a different set of guardrails than another LLM, further down that call stack that maybe takes actions for you, etc. So there's like different custom guardrails that you really think about. I think the other key kind of reliability technique is like designing for uncertainty. So designing in a way so that you're able to really recover from uncertain behavior by the AI system, and then as needed loop in the human on the other side, either like a supervisor or the human maybe user that's using that AI agent to give clarifying context, etc., to make sure that you're able to successfully execute. This is especially from the early era of AI agents to now. That's actually been a big transition that has made agents a lot more successful. And the third is, still systematic testing. So especially with agents, eval is just such a challenging problem. And when we talk to organizations today, that's like the big thing on top of their mind. So really deeply thinking about like, okay, can we proactively detect where my agent fails and then, build the necessary safeguards? So ideas like simulation testing there tend to be like really powerful. But I think this is still a very actively evolving space. So these are just some of the lessons I've learned, but I think it continues to, like as we're building and deploying more of these agents, I think we get more information from the environment, So the other thing I'd say is to like not be married or beholden to a certain method and, to continuously evolve as we get new information, etc.
Yeah, that's definitely sounds like a big challenge, right? That you're trying to tackle. And like, the industry is also trying to tackle as well. Like, how do you validate an AI agent's decisions, right, before it executes?
Yeah.
And also like looking at the whole guardrail architecture, especially now, you're not just looking at LM anymore or chatbots anymore, but actually, is it the right approach for agents,
Yeah,
basically?
yeah, yeah. That's exactly right. Yeah. Um,
So,
and I think, yeah, the other quick thing I'll mention here is that the most effective way to supervise agents is to use LLM judges. So you get more of the, AI supervising other AI, but that's unfortunately one of the few techniques that can be, as flexibly adapt to how complex AI agents typically tend to be.
Going back to AI safety, what would you say is like aspect or areas around AI safety that has not been discussed a lot yet?
Oh, that's a really good question. I have an answer here. I guess I have a view. My answer is really proposing a question, because I don't think there's a true real answer for this. But I think like one of my criticisms of the AI safety space, I'm on, a lot of panels, etc., talking about AI safety, and a lot of the challenges with AI safety, for example, tend to deal with problems that are technologically tractable, right? So this idea that we were talking about earlier, which is like, is the AI model harmful? Can it tell you, how to, for example, give you recipes for making explosives at home, or does it reinforce negative beliefs, etc., that you have? Can it cause you to be more isolated from your environment, etc.? All of those are much more tractable harms that can be solvable from a technology perspective. But I think like one harm that is very under discussed when it comes to AI safety is just, its impact on the kind of like workforce economy. So specifically the idea that, especially a lot of knowledge work, which was historically, where, more societies were moving towards knowledge work, and that was where there was a lot of, um, um, I guess, progression in terms of, like lifestyle upgrades, etc. I think a lot of that is at most risk for being automated by AI systems. So, creative work, software engineering, etc. So I think like those, it's unclear what the impact of, once these AI systems continue to get better and better, like right now is the worst that these AI systems are. And even now, the amount of usefulness that they provide is just so vast that it was unimaginable even a few years ago, right? So as these systems get better and better, what happens to the workforce? What happens to job requirements? And, what are the jobs left for humans to do? And unfortunately, this is not something that you can solve, for example, with like guardrails, etc. So I think it tends to be like typically under discussed in a lot of these forums.
Thank you for sharing, Shreya. Today, we've covered going from POC to implementation to where we are going in the future. Someone watching this might go back to the company on Monday morning. Their CEO might ask, hey, should we be investing in AI safety and reliability right now? Can you give a 60-second answer to make the bet?
Um, I will say yes, depending on your stage. Especially if you're a large Fortune 500 organization or a very large enterprise, AI safety is typically going to be a huge unblock for you to kind of adopt AI. Often we end up seeing that there's a graveyard of AI projects because you often don't, adapt the risk framework that you apply to all other software technology to AI systems because of the lack of knowledge or just frameworks there. So investing early in AI safety means that you're able to unblock a lot of the innovation and development that you can do in AI, and allows you to kind of like keep up with the times, right? So rather than, building an AI agent and then spending like 6 to 9 to 12 months just getting internal approval, if you have a very robust AI safety and AI testing framework internally, you can really substantially speed that up so that you can innovate faster.
Shreya Rajpal, CEO of Guardrails AI, thank you for the conversation. For the audience, if you want to learn more, Guardrails is open source. You can get started with it. Shreya, thank you for your time.
Yeah, thank you so much for inviting me, Nisha. Really enjoyed our conversation.
Same here.